There might be a technical problem. It was disconnected. Okay. To find y dash of 0, we differentiate this expression throughout with respect to x. Derivative of y is y1 or y dash. Either way, you can write that. This is equal to derivative of log 1 plus tan x is 1 divided by 1 plus tan x into derivative of log 1 plus tan x is 1 over 1 plus tan x into derivative of 1 is 0. 1 is a constant and derivative of tan x is secant square x. That's what I have written here. y1 is equal to secant square x divided by 1 plus tan x. Now put x is equal to 0. When x is equal to 0, y1 will be y1 of 0. This is equal to secant 0 is 1, therefore 1 square is 1 divided by 1 plus tan 0 is 0, 1 plus 0 is 1 and 1 by 1 is 1. Therefore y1 of 0 is equal to 1. Next, y2 is required. In order to obtain y2, we have to differentiate y1 with respect to x. To avoid using quotient rule, we can write this expression as y1 into 1 plus tan x. Like this is equal to secant square x. First, we differentiate this left hand side using product rule. 1 plus tan x into 1 plus tan x into derivative of y1 is y2 plus derivative of 1 plus tan x is secant square x into y1 as it is. Secant square x into y1 as it is. This is equal to derivative of secant square x is 2 secant x into derivative of secant x is secant x into tan x. Secant x into tan x. Therefore, 1 plus tan x into y2, this term. 1 plus tan x into y2 plus secant square x into y1, this term. Secant square x into y1 is equal to 2 into secant x into secant x can be written as secant square x tan x as it is. Now put x is equal to 0. When x is equal to 0, this will be 1 plus tan 0. Tan 0 is 0. 0 plus 1 is 1. 1 into y2. y2 means y2 of 0. Plus secant 0 is 1 and 1 square is 1 into y1. And we know that y1 at x is equal to 0 is 1. 1 into 1 is 1. Is equal to here tan 0 is 0 and 0 into anything is 0. Therefore, y2 of 0 is equal to transform this plus 1 to right hand side, we get to minus 1. y2 of 0 is equal to minus 1. Now we have to find third derivative. To find the third derivative, we differentiate this expression again with respect to x. Differentiate. First, we differentiate this term. 1 plus tan x into derivative of y2 is y3 plus derivative of 1 plus tan x. 1 is constant, its derivative will be 0, and derivative of tan x is secant square x into y2 as it is plus. Now differentiate this term. Secant square x is first function and y1 is second function. Secant square x first function into derivative of y1 is y2 plus derivative of secant square x is 2 secant x into derivative of secant x is secant x into tan x into y1 as it is, this y1. This is equal to, now differentiate right hand side. 2 secant square x is to be treated as first function, keep it as it is. 2 secant square x into derivative of tan x is secant square x plus. Now differentiate 2 secant square x. Derivative of 2 secant square x is 4 secant x. Into derivative of secant x is secant x into tan x. Into this tan x as it is. Now to find y3, put x is equal to 0. When x is equal to 0, tan 0 will be 0. 0 plus 1 is 1. 1 into y3 is y3. y3 means y3 of 0 plus secant 0 is 1. 1 square is 1 into y2. y2 is minus 1. 1 into minus 1 is minus 1 plus. Again, secant 0 is 1. 1 square is 1 into y2 is minus 1. And here, this will be tan 0. Tan 0 is 0. 0 into anything is 0. This is equal to, here secant 0 is 1. Here also secant 0 is 1. 1 into 2 is 2. And here tan 0 is 0 and 0 into anything is 0. Therefore, y3 of 0 is equal to, transform this minus 1 minus 2 to right hand side. 2 plus 2, 4. y3 of 0 is equal to 4. To make a note of this. Still we have to write this series, substituting this series. Y of 0 is equal to 0, y1 of 0 is equal to 1, y2 of 0 is equal to minus 1. y3 of 0 is equal to 4. y3 of 0 is equal to 4. Now this is the Maclaurin's series. Up to third degree, this is not required. Substitute up to this term. Y of 0 is equal to 0, leave it. Y of 0 is 0. Plus x into y dash, and y dash is 1. Therefore, x into 1 is x. Plus x square divided by 2 factorial. 2 factorial means 2 into 1, that is 2. Into y double dash is equal to minus 1. Y double dash means y2 minus 1. Plus x cube divided by 3 factorial. 3 factorial is 3 into 2 into 1, that is 6. Into y triple dash. Y triple dash is 4. Therefore, x as this, plus into minus x square divided by 2 plus x cube, 4 by 6 can be written as 2 by 3. This is the Maclaurin's expansion up to third degree. If you have any doubts, you can mention in chat box or message me later also. Is it clear? Responding chat box. I asked, is this clear? Okay. Next, we move to the next problem. Obtain the Maclaurin's series of e power x into sin x up to the fourth degree term. Up to fourth degree term. Maclaurin's series is y of 0 plus x into y dash 0 plus x square by 2 factorial into y double dash 0 plus x cube by 3 factorial into y triple dash 0 plus x power 4 by 4 factorial into fourth derivative at x is equal to 0 up to fourth degree term. And it is given that y of x is equal to e power x into sin x. Y of x is equal to e power x into sin x. First term is y of 0. Therefore, we have to find y of 0 by substituting x is equal to 0. When x is equal to 0, this will be e power 0 into sin 0. Sin 0 is 0. Therefore, 0 into anything is 0. Y of 0 is equal to 0. You have to differentiate this successfully 4 times with respect to x. Differentiate first time. Derivative of y of x is denoted by y1 of x. Use product rule here. E power x is first function, keep it as it is. Derivative of sin x is cos x. Plus keep sin x as it is. Second function, derivative of e power x is e power x itself. Here e power x is common in both the terms, keep it outside. Then what you get within the brackets is cos x plus sin x. Cos x plus sin x. E power x into cos x plus sin x. That's what I have written here. Now put x is equal to 0. When x is equal to 0, this will be e power 0. E power 0 is 1 into cos 0. Cos 0 is 1 plus sin 0. Sin 0 is 0. Therefore, this is equal to 1. y1 of 0 is equal to 1. Next, to find y2, we again differentiate this expression with respect to x using product rule. This is first function and this is second function. Derivative of y1 is y2. y2 is equal to first function e power x into derivative of cos x plus sin x. Derivative of cos x is minus sin x plus derivative of sin x is cos x plus derivative of e power x is e power x itself, and keep second function cos x plus sin x as it is. Cos x plus sin x. Here e power x is common in both the terms, you keep it outside e power x. As e power x comes outside, we get minus sin x plus cos x. Minus sin x plus cos x plus cos x plus sin x. Cos x plus sin x. Cancel this minus sin x with this plus sin x. What we get here is e power x into cos x plus cos x is 2 cos x. 2 into e power x into cos x. This is y2. Next, put x is equal to 0. When x is equal to 0, this will be y2 of 0. When x is equal to 0, y2 of 0 is equal to 2 into e power 0. E power 0 is 1, cos 0 is 1. Therefore, 2 into 1 is 2. y2 of 0 is equal to 2. Second derivative, y2 of 0 is equal to 2. To find y3, we again differentiate this expression, treating 2 into e power x as first function and cos x as second function. Differentiated. Derivative of y2 is y3. y3 means y3 of x. This is equal to, keep 2 into e power x as it is, first function. Derivative of cos x is minus sin x plus derivative of 2 into e power x is 2 into e power x itself into cos x. This is equal to, here 2 into e power x is common in both the terms, keep it outside. 2 into e power x. What we get within the brackets is cos x minus sin x. Cos x minus sin x. That's what I have done here. 2 into e power x into cos x minus sin x. To find y3 of 0, put x is equal to 0. When x is equal to 0, this is y3 of 0 is equal to, right hand side will be 2 into e power 0. d power 0 is 1. 1 into 2 is 2. And here this will be cos 0. Cos 0 is 1. Minus sin 0 is 0. Therefore, this is equal to 2. y3 of 0 is equal to 2. Third order derivative. Now we find a fourth derivative. Fourth derivative. Fourth derivative is obtained by differentiating y3 with respect to x. Derivative of y3 is y4. y4 of x is equal to, differentiate this. This is first function and this is second function. Keep first function 2 into e power x as it is. Differentiate. Derivative of cos x is minus sin x minus derivative of sin x is cos x. First function 2e power x into derivative of cos x is minus sin x minus derivative of sin x is cos x plus derivative of 2 into e power x is 2 into e power x itself into cos x minus sin x as it is. This is equal to, here 2 into e power x is common in both the terms, keep it outside, 2 into e power x. What we get within the brackets is minus sin x minus sin x minus 2 sin x minus 2 sin x minus cos x will get cancelled this plus cos x. Therefore, this is equal to 2 into minus 2 minus 4 into e power x into sin x minus 4 into e power x into sin x. Next, to find y4 of 0, put x is equal to 0. Put x is equal to 0. When x is equal to 0, this will be sin 0. Sin 0 is 0 and 0 into anything is 0. Y4 of 0 is equal to 0. One more derivative is required because expansion is required up to 5th degree term. Again, differentiate this, keeping minus 4 into e power x as first function and sin x as second function. Derivative of y4 is y5. Y5 of x. Minus 4 into e power x is first function, keep it as it is. Derivative of sin x is cos x. Plus derivative of minus 4 into e power x is minus 4 into e power x itself into sin x. Here, minus 4 into e power x is common in both the terms, keep it outside, and we get cos x plus sin x inside the bracket. Cos x plus sin x. This term. Now put x is equal to 0. What we get here is y5 of 0 is equal to, here e power 0 is 1, 1 into minus 4 is minus 4, and within the bracket, this will be cos 0 is 1, and sin 0 is 0. Therefore, minus 4 into 1 is minus 4. We obtained all the 5 derivatives. Now we can easily write the Maclaurin's series. Y of 0 plus x into y dash of 0 plus x square by 2 factorial into y double dash 0 plus x cube by 3 factorial into y triple dash 0 plus x power 4 by 4 factorial into fourth derivative, and next term will be x power 5 divided by 5 factorial into fifth derivative at x is equal to 0. Substitute y of 0 is equal to 0. Leave it. Plus x into y dash of 0. Y dash of 0 is 1. 1 into x is x. Plus x squared divided by 2 factorial. X squared divided by 2 factorial is 2 into 1, 2. Into y double dash 0 is 2. Cancel this 2 with this 2. We are left with x squared plus x cube divided by 3 factorial. X cube divided by 3 factorial means 3 into 2 into 1, 6 into triple dash. Triple dash is 2. 2 by 6 is 1 by 3. Therefore, x cube divided by 3. Plus x power 4 divided by 4 factorial into fourth derivative is 0. 0 into anything is 0. Plus x power 5 divided by 5 factorial is 5 into 4 into 3 into 2 into 1, 120. Into fourth derivative is minus 4. Therefore, this is minus x power 5 divided by 120 is exactly divisible by 4, 30 times. Therefore, minus x power 5 divided by 30. Please make a note of this. If you have any doubts, you can respond in chat marks. Is this clear? Now you can hear, right? Abhinav? Okay, we'll start. Expand e power a into sin inverse x in ascending powers of x. In ascending powers of x, a degree of the expansion is not specified. We can expand up to third degree. It is not specified here. Expand up to third degree. Sometimes they will not specify. In such cases, you expand up to third or fourth degree. It's up to your convenience. I prefer to expand up to third degree for particular this problem. Y is equal to e power a sin inverse x. Y is equal to e power a sin inverse x. This is the given function. That means y of x. Y of x is equal to e power a into sin inverse x. Here y means y of x. Put x is equal to 0. When x is equal to 0, this will be e power a into sin inverse 0. And sin inverse 0 is 0 itself. Therefore, collectively, this is e power 0 and e power 0 is 1. This is not 0, this is 1. Y of 0 is equal to 1. Next. This is 1. To obtain y1, we differentiate this expression with respect to x. The derivative of y is denoted by y1. This is equal to derivative of e power a into sin inverse x is e power a into sin inverse x itself. Into derivative of a into sin inverse x. A is a constant, keep it as it is. Derivative of sin inverse x is 1 over square root of 1 minus x square. Okay. Derivative of d by dx of sin inverse x is d by dx of sin inverse x is 1 divided by square root of 1 minus x square. That's what I have done here. E power a into sin inverse x into a divided by square root of 1 minus x square. Now to find y1 of 0, put x is equal to 0. When x is equal to 0, this will be y1 of 0. Y1 of 0 is equal to, when x is equal to 0, this will be e power 0. E power 0 is 1. E power a into sin inverse 0. Sin inverse 0 is 0. 0 into a is 0. E power 0 is 1. Numerator will be 1. Into a. This a. Divided by square root of 1 minus x square. X is equal to 0. Therefore, square root of 1, that is 1. Therefore, clearly this is equal to a. Y1 of 0 is equal to a. Next, to avoid applying quotient rule, we can simplify this as square root of 1 minus x square into y1 is equal to square root of 1 minus x square into y1. This term, root 1 minus x square into y1 is equal to a into this a. E power a sin inverse x. E power a into sin inverse x. Therefore, square root of 1 minus x square into y1 is equal to a into e power a into sin inverse x is denoted by y. To eliminate this square root, square on both sides. What we get here is 1 minus x square. Square root of 1 minus x square whole square is 1 minus x square into y1 is equal to y1 square. If you square it, square root of 1 minus x square is 1 minus x square into y1 square is equal to a square into y square. That's what I have written here. 1 minus x square into y1 square is equal to a square into y square. Now differentiate this expression throughout with respect to x. In order to obtain y2, we differentiate this expression with respect to x. First, we differentiate this term. 1 minus x square is to be treated as first function and y1 square as second function. 1 minus x square into derivative of y1 square is 2y1 into y2. 1 minus x square into derivative of y1 square is 2y1 into y2 plus derivative of 1 minus x square is minus 2x into y1 square as it is. This is equal to a square is a constant, keep it as it is. Derivative of y square is 2y into derivative of y is y1. What is common factor here? 2 is common in all the three terms, therefore we can divide the expression throughout by 2. y1 is common in all the three terms, therefore we can divide by y1 also. Therefore divide the expression throughout by 2y1. Divide the expression throughout by 2y1. What we get here is 1 minus x square into y2. This 2y1 will get cancelled with this 2y1. Plus into minus minus x into 2y1 will get with this 2y1, which will get cancelled with this 2y1, and we are left with y1. This is y1 square. This is equal to, cancel this 2y1 with this 2y1, we get a square into y. 1 minus x square into y2 minus xy1 is equal to a square into y. Now put x is equal to 0. When x is equal to 0, this will be 1 minus 0 square, that is 1. 1 into y2 is y2. y2 means y2 of 0. Since x is equal to 0, x into y1 is also 0. This is equal to a square into y, and y is equal to 1. A square into 1 is a square. This is 1. Therefore, y2 of 0 is equal to a square. y2 of 0 is equal to a square. Again, differentiate this expression with respect to x. First, we differentiate this term. First function 1 minus x square into derivative of y2 is y3. Right here, 1 minus 1 minus x square into derivative of y2 is y3. And derivative of 1 minus x square is minus 2x into y2. Now we differentiate minus x into y1. Minus x is first function, keep it as it is. Derivative of y1 is y2. And derivative of minus x is minus 1 into y1 is equal to a square is constant, keep it as it is, into derivative of y is y1. Therefore, 1 minus x square into y3 minus 2xy2 minus xy2 is minus 3xy2 minus y1 is equal to a square into y1. This expression. Now put x is equal to 0. When x is equal to 0, this will be 1 minus 0 square, that is 1 into y3. y3 means y3 of 0. Minus 3x into y2, but x is equal to 0, therefore 0 into anything is 0. Minus y1. y1 is a. Is equal to a square into y1. y1 is again a. Therefore, y3 of 0 is equal to a square into a is a cube plus a. Or this can be written as a into 1 plus a square. Now write the Maclaurin's series up to third degree term. Maclaurin's series is given by y of x is equal to y of 0 plus x into y dash of 0 plus x square by 2 factorial into y double dash of 0 plus x cube by 3 factorial into y triple dash of 0 up to this term. Y of 0. Y of 0 is 1 plus x into y dash of 0. Y dash of 0 is a. Therefore, a into x. X square divided by 2 factorial into y double dash. Y double dash is a square plus x cube divided by 3 factorial into y triple dash of 0 is a into 1 plus a square. So please make a note of this. And mark your attendance in the chat box. Mark your attendance. One more similar problem. Obtain the MACLAURIN'S expansion of sine inverse x up to the term containing x power 5. That means you have to differentiate 5 times with respect to x. It's given that y of x is equal to sine inverse x. Put x is equal to 0. When x is equal to 0, this will be y of 0 is equal to sine inverse 0. Sine inverse 0 is 0. Differentiate. Derivative of y is y1. y1 of x is equal to derivative of sine inverse x is square 1 divided by square root of 1 minus x square. This is a known derivative. Derivative of sine inverse x is 1 over square root of 1 minus x square. Put x is equal to 0. When x is equal to 0, this will be y1 of 0. This is equal to, here x is equal to 0. Therefore, 1 divided by square root of 1 is 1. To avoid using quotient rule, we can simplify this as square root of 1 minus x square into y1 is equal to 1. To eliminate this square root, square on both sides. Square root of 1 minus x square whole square is 1 minus x square into y1 square is equal to 1 square is 1. Now differentiate. Differentiate both sides with respect to x using product rule. This is to be treated as first function and this one as second function. Let's differentiate. 1 minus x square into derivative of y1 square is 2y1 into derivative of y1 is denoted by y2. And derivative of 1 minus x square is minus 2x into y1 square. This is equal to 1 is a constant, its derivative must be 0. What is common factor here? 2 is common in both the terms, y1 is common in both the terms. Therefore, we can easily divide the expression throughout by 2y1. Resultant will be 1 minus x square into, cancel this 2y1 with this 2y1, we get y2. 1 minus x square into y2. Cancel this 2 with this 2 and 1 y1 with y1 here. We get minus x into y1 is equal to 0. Now put x is equal to 0. When x is equal to 0, this expression will be 1 minus 0 square, that is 1. 1 into y2 is y2. Here y2 means y2 of 0. Since x is equal to 0, x into y1 is 0 is equal to 0. y2 of 0 is equal to 0. This is second derivative. You have to expand up to 5th degree. Find y3, y4 and y5. y3 of 0 is equal to 1, y4 of 0 is equal to 0 and y5 of 0 is equal to 9. To differentiate the previous expression, this is the previous expression to obtain y3. To obtain y3, we have to differentiate this. 1 minus x square into derivative of y2 is y3. Derivative of y2 is y3. Derivative of 1 minus x square is minus 2x into y2 as it is. Here minus x is first function, keep it as it is, and derivative of y1 is y2. Derivative of minus x is minus 1 into y1 is minus y1 is equal to 0. Therefore, 1 minus x square into y3 minus 2xy2 minus xy2 is minus 3xy2 minus y1 is equal to 0. Put x is equal to 0. When x is equal to 0, this will be 1 minus 0 square, that is 1. 1 into y3 is y3. y3 means y3 of 0. Here x is equal to 0, therefore 0 into anything is 0. Minus y1 and y1 is equal to 1 is equal to 0. Therefore y3 of 0 is equal to 1. y3 of 0 is equal to 1. So y3 of 0 is equal to 1. Let's see. To find y4, you again differentiate this expression. You get y4 is equal to 0. You do it by yourselves, y4 and y5. You get y4 is equal to 0 and y5 is equal to 9. You can do it by yourselves. We are left with only 1 minute. You note down this answer. Y4 is equal to 0 and y5 is equal to 9. Thank you.